One of the most important modules on a modular synthesizer is a filter, also known as a VCF, or voltage-controlled filter. You'll notice that a lot of modules have a voltage-controlled component to its name, which simply means that the module can be controlled and modulated by voltage signals coming from other modules. This is something we'll dive into a little bit later. Now, a filter is a module that helps shape the harmonic content or timbre of a sound source by filtering out certain harmonic elements of the sound. There are two filters in this modular system we're using. The first one is the System 8860 filter, which is based on a very popular design of old Roland synthesizers. And the second filter we have is the Doepfer A121-3, which actually has very similar functions, but is built in a smaller footprint with things arranged slightly differently. Now, on almost every filter, you're going to find the following controls and patch points. There's always a signal input and a signal output. There is always going to be a frequency control on a filter. Now, the frequency control sweeps through the frequency spectrum of an incoming sound and determines the point at which the filter starts to block out parts of the sound. Usually, the best way to demonstrate a filter is by hearing it. So we're going to hear the simple patch. We have a sawtooth wave coming out of the oscillator and into the input of the filter. The output of the filter is patched to the VCA like we did before, and then the VCA into the camera. If I turn up the VCA, you're going to hear the melody that we heard in the last video because I have the sequencer still connected to the keyboard input. If I start to turn the frequency knob on the filter, it starts to cut out some of the upper harmonics of that sawtooth wave. And here we're using a low-pass filter. So filters can operate in a few different ways. A low-pass filter, which is probably the most commonly used type of filter on a synthesizer, allows any sound below the filter frequency to pass, hence low pass. So if I set the frequency quite low, it gets quite muffled because it's cutting out all the upper harmonics of the sawtooth wave. On this particular module, there's a switch that allows us to change the type of filter. So if I press the switch, we're going into a bandpass mode. Now, a bandpass filter cuts off anything above or below the set frequency and only allows a narrow band of harmonic content to pass through. So if I sweep through the filter frequency, you'll kind of hear this very thinned out sound because it's only allowing a thin range of harmonic elements to pass through the filter. And the last type of filter on this module is the high-pass filter, which does the opposite of the low-pass. So it allows anything above the frequency to pass and then cuts off a lot of the lower harmonics. So I'm going to press the switch again. And the lower I turn the filter, the more of the lower harmonics you're going to hear, right? And the more I turn up this high-pass filter, the bottom starts to thin out. And you're only hearing the highest harmonics that is allowed to pass through. We're going to go back to the low pass. Now, the other control you'll commonly see on a filter is usually labeled resonance, which we do find on the 860 as well as on our Doepfer VCF, where it's labeled Q. So resonance or Q is the same parameter on a filter. And the resonance of a filter accentuates the harmonic content at the filter frequency point. And this is the control that gives that characteristic whistly quality to filters. So if we set the frequency point here, and we increase the resonance, and starts to sweep the frequency again, you hear this squelchy quality, this rubbery quality, which is the resonance of the harmonic content at the frequency cutoff point. And it's applied to every type of filter. This is the bandpass filter, and this is the high-pass filter. And the more resonance you add, the more squelchy it gets. And this is that kind of familiar sound that we hear in a lot of electronic music. And different filters have different resonant properties. And so a lot of times, a synthesizer is not so much characterized by the quality of the oscillators or other components, but the quality of the filter or the design of the filter.